welcome to another episode of MrLopezClasses.com and Marine Technical Training Academy. Today we are going to talk about electric vehicles, electric cars. And in particular for this video, we are going to visit Sena in Colombia, in Valle del Cauca. You remember the Professor Oscar, the Professor Julian in Cali? Yes. They are working with the conversion of electric cars, electric vehicles, and they have in this opportunity a Renault Kangoo. It's a full electric car, and I want to explain the components of the full electric car. I want that you be familiarized with those components. Why? Because what is my idea? My idea is in the future episode, in the future videos, explain the process to convert any type of car, gas or diesel, into hybrid or full electric car. The same with the boats. You can convert the boat inboard or outboard into full electric or hybrid boat. And the same with airplanes. And we are going to do those videos per boats, per airplanes, per cars, exactly the same, following the same criteria. And you remember this is a previous, a little introduction to understand the electric car, the electric vehicle. You remember that slide that I used in my course of transmission, marine transmissions? Yes, this is the typical car. As you can see, this is the engine. The yellow one is the clutch, mechanical or hydraulic clutch. The red one is the transmission. In Spanish is la caja de cambios. It's exactly the same, the transmission. The shaft is the green, the differential is the purple, and the wheels. This is your car. This is the car that you have in your home. All right. And this is a boat. It's basically the same engine. The transmission is the blue one. It's a marine transmission. A little different. It's basically the same. The shaft and the propeller. Yes, you can convert the automotive car into marine. It's pretty simple. In a lot of my episodes of diesel and gasoline engines, I explain that process. Okay, this is the configuration of the boat, and this is the configuration of the car. It's basically the same. Okay, can I remove that engine, gasoline or diesel engine, and replace the engine for an electric motor? Yes, you can. What type of motor? Okay, today, according with the advance of the technology, we discovered that the best motor is an AC motor, three-phase induction motor. You can with DC, yes, but with DC you drain the batteries too quick, and it's not efficient in comparison with AC, especially three-phase, because remember, in three-phase you have less consumption of amps, and you drain the batteries slow, and you produce high torque and ultra high speed. This is a great advantage. Okay, what is the configuration that we are going to analyze today in the Renault Kangoo that Oscar and Julian, they have in Sena, Colombia, the biggest technological institute in Colombia. They have a Renault Kangoo full electric. They received the Renault with some issues in the battery charger. They discovered the issue, they repair, and they solved the problem. And I used that opportunity to record this video for you and explain the components of the electric car, the electric vehicle. And in particular, this is basically the configuration, the picture of that car. But this is basically the picture, the configuration of any electric car. Doesn't matter if it's Renault or Chevrolet or Ford, it's basically the same. What are the components of those electric cars? Okay. The component number one is the electric motor. The electric motor, AC motor, three-phase motor. This one. And of course, the electric motor needs power, AC power. The AC power is coming from the inverter. The inverter converts DC power DC power coming from the battery bank in the rear of the car, the battery bank, and convert that electric power DC into AC three phases, 1, 2, and 3. Those three phases to feed the electric motor, the three-phase electric motor. That's wonderful. Okay, and the battery bank in the back receives charge from the battery charger. And the battery charger is connected to the short power cable. Simple. Of course, that battery bank is a big battery bank, it's a huge battery bank. The voltage is 358 volts DC, a lot of voltage. Okay, that power, 350, is used in two ways. One way, enter in the voltage regulator, and after that in the inverter to supply power for the motor, number one. The second one is for power in the rest of the car, in the accessories, in the lights, in the radio, in the music, the air condition. Yeah, but those elements are 12 volts. Okay, for that reason we are going to install the DC to DC converter to convert 350, 360 volts DC. In this particular case, in other models is 400 something or 500 volts DC. You need to convert that huge voltage into 12 volts. For the dashboard, for the AC unit, the power steering system, the power windows, accessories, a lot of accessories that you have in your car, you need 12 volts. That's it. And how can I regulate the RPMs in the electric motor? Oh yeah, because you have that small box in the bottom of the electric. This is the frequency driver. The frequency driver to control RPMs. And the frequency driver is connected with the gas pedal. More RPMs, less RPM. This is a frequency driver in this particular case because this model use an AC motor. The only way to control RPMs in an AC motor, induction motor, is with a frequency driver. That's it. Those are the components. Okay, of course, the electric motor engaged with the gearbox. What is the gearbox? It's the transmission. In Spanish, la caja de cambios. And the gearbox engaged with the differential. What is the differential? It's the element that converts the output torque produces for the transmission into power and torque for the wheels. That's the differential. Correct. That's the differential. In this particular case, that Renault Kangoo have a traction in front. Two wheels in front, and this is the connection. One shaft for one wheel, the other shaft for the other wheel, and this is the electric car. This is the configuration, the schematic of the electric car. Yes, in other words, you can convert any type of gasoline or diesel car into electric, full electric or hybrid. This is the schematic for a full electric. Why? Because in this particular case, the battery bank receive power from the battery charger, and the battery charger receive power, AC power, from the short power in the pedestal. Yes, in this particular design, you can drive your car until the level of batteries reach the minimum recommended by the manufacturer. Oh, can I convert a little this design into hybrid? Yes. The only that you need added is a small generator to recharge the battery bank. This is I have a hybrid configuration. I have a hybrid configuration here in a boat. You see, I have the motor, the AC motor. I have the gearbox or transmission, the shaft, and the propeller. The AC motor receives power from the inverter. And the inverter receives DC power from the battery bank, and the battery bank is charged from solar panels, or from windmill, or from the battery charger. Nice. How can I activate the battery charger? With a small generator. That generator on top. When the generator is running, send power to the AC panel. In the AC panel, I have one breaker dedicated for the battery charger, and the battery charger recovers the level of charge on my batteries. How can I control that the batteries are not overcharged? Because I have that small a.c.r, automatic charging relay. Or MPPT is exactly the same. Later in other episodes I'm going to explain that. This is a hybrid boat, but you can do the same with your car. You added this element, the generator, the battery charger, and the AC panel. And you convert that electric car into hybrid. This is another episode. I am going to explain that. Today we are going to be concentrated in this electric car. And we are going to analyze with Professor Oscar all of those components. We are going to analyze, number one, all the components, to all the parts of the schematic. And this is the analysis. Ah, the battery charger. Oh, wow.
Nice. The charger is different. And this device you can connect inverter, a compressor.
Only charger?
It's only charger. Let me show you the inverter. This is inverter. Look, it working 40 to 20 voltage.
Yeah.
This is inverter. Look.
Phase 1, 2, and 3. This is the input DC, and this is the output AC, 3 phases. That's the inverter. That's great. And we are going to check the plate. In the plate they say that the output voltage is 420 volts AC. That's great.
The connection of the...
this is the harness. Yeah, this is the harness entering here.
Yeah. To the... Yeah, that's right.
Okay, we have the motor. We have the inverter. The inverter produces AC power and enter into the electric motor 3-phase. And over here we are going to install the battery charger.
Yeah.
Oh wow, nice, nice. And all of them cooled by coolant. Battery charger.
The charger, inverter, and the propulsion motor, electric motor or machina.
Battery charger, inverter, the inverter to the motor, electric motor to the transmission, to the shaft, wheel, and wheel. This is a perfect, fully electric design. Nice. Thank you. Thank you. Perfect. And all of them are cooled by coolant.
It's not bad deal, only in Colombia, because in Valle del Cauca tried to make this work because
in Cali.
In Cali, you know, the salsa city. Cables, sure.
Ah,
you know,
nice.
Different China's
This is the short power cables.
Yeah, inside there is a resistance that give you
if you
the
have a short or
the intense.
Yeah, correct.
This cable you pull in this part
to connect to the outlet of the car. Correct. And that one in the pedestal in your hand. That's correct.
Yeah.
Yeah. Nice, no? Those are the main components. Okay, we are going to start the analysis with the battery bank. How is the configuration of the battery bank? What is the voltage of the battery bank? How are the terminal, the plugs of the battery bank? This is the analysis of the battery bank. This is a special rubber for ultra high voltage.
Yeah. In fact, you had to prove before you use them. Yeah, how to prove? You have to say before someone give the gloves, show me if the gloves are good. So how?
If you don't have leaks.
Yeah. No leaks.
No leaks, yeah.
It's good. The table. Okay.
Okay guys, this is the battery bank for a fully electric Renault Kangoo.
Look, this cover has, you know.
This is basically for removal of gases.
Yeah, gases.
That's okay, that's great. And because those are sealed batteries, but they produce a little amount of gases. That's
right.
correct.
We have to put that.
Okay, we are going to check the plate. No, this is the time of construction, 28/12/2019.
LG.
LG.
The other one it was Kefico. This is LG.
All right. Remember that this is an inverter charger. Internally, all the inverters, they have a small battery charger to keep the battery bank fully charged.
As you see the harness, every cable.
The color code.
Yeah, a color code and information about tension, amps, balance of every
temperature and load.
Every cells are gonna make the tension that have this battery. So and
DC.
This DC. So I'm gonna take the measure for this side. This one and the other one.
358 volts DC. 360 practically volts DC. Great. This is the output voltage of this battery bank. Wow. 360 volts DC.
Okay.
And now we are going to analyze the harness and how the harness passed to the ducts in the car. And also we are going to check the compartment on the car for the battery bank. Where is located that compartment and how those harnesses are protected to avoid moisture and humidity entering in the harness. This is the analysis. And we are in the in the back of the Renault Kangoo. This is very important. This is the area. This is the compartment that originally, if the car is with a petrol engine, gas or diesel, this is the fuel tank. But we checked the battery bank a couple of minutes ago, and the battery bank, the electric battery bank, have the same shape. This is a great idea, no?
Yeah, it's a retrofit industry.
It's designed to the possibility to convert in the future.
Yeah,
that's
come
great.
back.
Yeah, that's great. And okay, the battery bank is here, and after that the harness travel. But originally this tunnel is not covered; it's empty.
Yeah, it's empty.
Your upgrade is that you cover, no?
Yeah, in the Kia made that difference. Try to put a cover that give up security, you know, and more careful.
Yeah, it's better. It's more safe.
More safe.
And you improve no humidity, no dust, no moisture in the harness. The harness is completely dry all the time. Okay, this is the harness coming from the battery bank and entering in the system that we explained outside. Electric motor, battery charger, and inverter.
In fact, we are going to put down again the car and gonna show you
the engine compartment.
Yeah.
The engine compartment.
In this place.
Okay, all right. That's perfect.
Do you remember the last time?
Exactly. Yesterday we checked motor, battery charger, and inverter and battery charger. That's the battery charger on top.
Auxiliary battery is important because
that battery is for the harness.
It fits all around low voltage.
Yeah.
It have a problem with battery auxiliary battery.
Yeah.
You
don't have nothing in the display in the dashboard.
Even the car don't run.
Okay. Yeah, because you don't have signals.
Yeah, I don't have signals. Okay. Yeah. And then look, this is my last. How can I say that?
Your explanation about the temperature sensor, the compressor, and the fuses.
Yeah. I was talking about the air conditioner because the air conditioner sometimes has a problem because the compressor is not.
It's not working.
It's not working.
The compressor for the air conditioning in these fully electric cars is similar to the compressor in marine. It's an electric compressor. You remember, guys, I explained the electric compressor. It's exactly the same. But this compressor is DC. It's DC, no AC. In the marine is AC. But that's why you need a converter, DC to DC converter. Nice analysis. Yeah, the harness should be protected. The harness should be sealed to avoid moisture. Moisture is the enemy. And now we are going to test, we are going to drive the car with Professor Oscar.
Hey, Mr. Lopez, come on over here.
Ay, ay, ay.
Have you ever experienced driving electric car?
Never.
Never?
Never. No hybrid, no full electric.
Easy.
It's the
Take
same.
the keys. I'm gonna show you. It's easy, like driving a toy cars.
Okay. All right.
Okay, you have to look on the
On the key, ignition switch. All
Switch
right.
on. Switch on.
Okay, press.
No, there is no problem.
No
Oh,
problem. On.
Switch on. Okay. In this part, you see a stop. Okay.
Okay, yeah.
Stop. Pull on the brake.
Yeah, brake.
Yeah, there is nothing. No.
Yeah,
Nothing to see.
disappear the screen.
Yeah,
All right.
you have to see go. Okay, one more time. Put the key off.
Off.
Put you
Brake.
Yeah, the brake.
Apply the brake.
On. Yeah, go.
Okay.
Can you see?
Yeah. Okay. We are going to start the car. That's the key. Introduce the key into the ignition switch. I turn on the ignition, and after that, go, and that's it. In this moment, the car is in parking. I am going to select for reverse, neutral, or drive. That's it. I am ready. I'm going to close the door, and the vehicle start. Bye bye, guys.
Okay guys, you enjoyed this episode? I hope you enjoyed the episode. I am preparing other episode explaining in details each of those components, the batteries, the harness, the regulator, and how to calculate, the procedure to sight, the procedure to calculate that, because this is the idea. My friend, if you enjoy this episode, please make a click. I appreciate that you evaluate my job, that your comments are very important for me. I love it, the feedback, because this is the only way to improve my job. Thank you for your support, because for your support is that this program continues. Thank you.